Hello, thanks for joining today. Today, we'll be developing and deploying a machine learning pipeline in 45 minutes with Plumber. My name is Eduardo Blancas. So before we start, would we share a few resources with you? Plumber, the package that we are going to be showing today, is open source, so you can go to github.com plumber, and you can get the code, you can read the documentation. And please show your support with a star on GitHub. We also have a community that you can reach out to us if you have any questions, if you want to learn more. The link for joining the community is on the GitHub's README. And finally, we've recently published a guest blog post on the official Jupyter blog, so you can check it out as well. Okay, so let's start with some motivation. Why does Plumber exist? I've been working in data science for a few years now, and I've noticed the same problem. Data scientists start working using Jupyter notebooks, then they prototype their models, and they have these gigantic notebooks where they put everything from getting data, cleaning data, generating features, evaluating models, generating predictions in a single file, a single big notebook, or maybe 2 or 3, but still the same thing. It's hard to manage these large files. And when you want to take things to production, usually teams have to refactor these Jupyter notebooks, so they turn the code into Python modules and then they deploy. What's the problem? That when you want to refactor these notebooks, you put deployment at risk. And I've seen this many times. You have Jupyter notebooks that work, and the moment you start to take things and move them maybe into Python classes or Python functions and organize them as a Python package, then things break. You may not be able to generate the same results. You may get different results. The model may not work as good as you expected it to work. And teams put the deployment at risk because of this practice, because they have to move things around, and many of these things will break. So as a solution, many teams require data scientists to write the Python modules from the beginning. And that sounds like might solve our issue, right? We just have Python modules and we take them to production. Well, turns out that's not really a solution. And what happens is that data scientists are still going to be using Jupyter notebooks, but instead are going to be copy-pasting code into these Python modules. So why do we data scientists like Jupyter notebooks so much, even if they have all these issues that make deployment a nightmare? Well, I think we need to really understand how analyzing data works. And really, Jupyter notebooks are a fantastic tool. Like, they allow us to write some code, get some results, get some tables, get some charts, explore the data. And that visual feedback is tremendously helpful when we are analyzing data. So that's why data scientists like Jupyter notebooks so much. So instead of trying to fix some practices and say, don't use Jupyter notebooks, put everything into a Python module. The idea of Ploomber is, let's fix all the issues that Jupyter notebooks have, and then help data scientists build more maintainable and reproducible pipelines from Jupyter. So they have the same experience, the interactive experience, the powerful Jupyter experience, but still they produce more maintainable work that doesn't require a whole refactoring for deployment. So how does the solution look like? The first thing is we use Python files as notebooks. And using the .py format helps with many things. It's much easier to manage with Git. And there are many other benefits, but I would say that the main benefit is that we can manage .py files easily rather than using the classic .ipynb format from Jupyter notebooks. The second part of the solution is that Plumber allows data scientists to break down analysis in multiple small tasks. So instead of having one big gigantic notebook, they have maybe like 5, 6, or 7 smaller files, and it's much easier to maintain and test because they have every single file has a specific responsibility. What this allows us is to test each task in isolation. And finally, since everything is a coherent pipeline, we can run from scratch continuously to ensure that the pipeline works. So overall, this creates a great solution, and Plumber brings, the idea is that Plumber brings software engineering best practices to the data science world. And just to give you some numbers and some idea of how much Plumber helps data scientists, Evidation Health, a healthcare technology company, reduced development time by 40% by using Plumber. They presented their results at PyData Global 2021, and the recording is going to be available soon, so you can check it out and see how they're using Plumber and kind of the things that help them reduce the development time and streamline the deployment process. Okay, so that's it for the explanation. Let's go to the fun part, which is developing and deploying the machine learning pipeline. All right, so we have 40 minutes left. So let's get started. The first thing is I'm going to start from scratch, so I don't have anything. Let me first use the Plumber command line interface to create a basic structure. So what I'm saying here is create an empty project just with some basic files that I need. And let's call these, let's wait for a few seconds. Okay, let's call this my project. All right, now let me move to that folder, and I have to modify. We are going to be using Jupyter Lab for the development. I just have to modify these files because we need to add a few things here. So for development, we need another package, pygraphbis. We need this to create a chart for the pipeline, and that's for development. And then for deployment, we also need two more packages. So we are going to be deploying to AWS, so we need this one, and we're going to create a evaluation chart, so we need this one, and I think that's it. That's all we need. Yeah, okay. So now let's create our environment. So Plumber install. This command is just generating a bunch of pip commands. We can use pip directly, Python and pip directly, but this makes things much easier. So it's going to start setting up our environment. We can just wait. It's going to take probably around one minute or two. So I'll just use the magic of pre-recording to skip until the end. All right, let's wait. All right, awesome. We got our environment working. So let's activate our environment, and now let's start Jupyter Lab. And we are going to start coding the pipeline. So remember, we are starting this from scratch. Let's give a few seconds to Jupyter so we can get going. Probably takes a few more. Okay, ready. Great. So now we are starting Jupyter Lab, and we see this pipeline YAML file. This is the central initial point for developing our pipeline. So what we need to create a pipeline in Plumber is to specify two things. The first thing is, where's my source code? What's the code that I want to execute? And the second part is, where's my output? So let's call this get.py, and this is going to create two files, a Jupyter notebook. So why a Jupyter notebook? That's because when Plumber executes Python scripts, it runs them as notebooks. So we create this report that's really helpful. So if we are running some, for example, some code that cleans the data, and it generates some tables, prints some statistics, generates some charts, when we orchestrate execution, we are going to get this as an output file, and then we can review it, and if we need to do some debugging, this is going to be really helpful, or even to generate reports from each execution. It's really, really nice to have this as an output. So remember, the get.py is our source code. The output notebook is an artifact of our pipeline. Okay, so that's it. And we actually need another output, because this pipeline, I'm going to be creating a machine learning pipeline. This is going to first generate some data. So it's going to create a CSV file. It's going to download some data, put it into a CSV file. But now let's accelerate things a little bit. And I already have the pipeline.yaml file. And I'm just going to explain things a little bit. So we have 5 tasks. And remember, the same thing happens. Source is our Python script, and then product is our output. So we have 1, 2, 3, 4, 5 scripts. Why do we break down our pipeline? And I kind of mentioned this in the introduction. Instead of having a single file? Well, turns out breaking down the logic in many parts makes it easier to test, to maintain, and also to parallelize, because if we have independent tasks, we can run them at the same time. And we also get incremental builds, which is really often when we are working in some data science project, we need to modify a tiny part of the pipeline. Let's say we change out the code that trains the model, we modify the parameters, and if we only modify this last part, we don't really have to execute the last part. Sorry, the first part, the first tasks. If we modify the last part, we don't have to modify the first task. So what Plumber does is keeps track of source code changes, and it only executes the things that it has to execute. And this is going to become clearer when I have the pipeline and then I execute it. So for now, we have one task that gets the data, two tasks that generate some features, then we join everything into a single CSV, and then we train a model. So I'm going to be using the iris dataset. Really simple, small data set just for the example. So now we declared our pipeline YAML file, but we haven't done anything else. So what I'm going to do is I'm going to execute Plumber scaffold, and this is going to generate all these scripts for me, so I can just go and open them. Okay, great. So now let me execute Plumber plot. Let me make this a little bit. Okay, right there. Yes. So now I'm going to generate a plot from our pipeline, and you're going to see something now. Pipeline.png. Okay, so Plumber recognizes our pipeline, and we have these 1, 2, 3, 4, 5 tasks. They don't have any order, which is what we are going to do right now, but Plumber recognizes these empty scripts. Okay, great. So now we have to start working on the actual code. So let's show a few things here. I'm going to be opening get.py, but remember, we want to edit this as Jupyter notebooks because it makes things a lot more interactive and easier for the data scientist, and that's what we want. And we need to do things fast because we have limited time. Okay, so what I did is right-click, open with, and then notebook. And now we have this .py file open as a Jupyter notebook. And what are we going to do now? We are going to write some logic to get some data. So we are going to get some raw data. I have the snippet right here. I don't want you to, the purpose of this presentation is not for you to see me coding in Python. The purpose is to see how dynamic Plumber is. So I'm just going to paste this and tell you what exactly I'm doing here. So sorry, this wasn't the right snippet. This one, yes. Okay, so I'm getting some raw data. Here you can see that I'm importing scikit-learn, loading the iris dataset. I load it as a data frame, and then I save it to a CSV file, and that's it. So we are just loading some sample data. Next, we want to generate a feature from the raw data. So we want to use this file as an input. So let's see how we do that in Plumber. And this is where I want to show you how easy it is to concatenate different scripts into a single pipeline that feel like we are only dealing with a single notebook. Okay, so now we are working with feature sepal. Yes, okay. So now we need the raw data because we are going to load the raw data, make some transformations, and then save the file, right? So Plumber has this special upstream variable, and I'm going to pass a list of tasks that I want to use as dependencies. So basically what has to execute before, and something's going to happen right now. So I just change this upstream equals get, a list with one element called get. Now let me reload this file, and you are going to see something happen here. So Plumber Plumber adds this code cell for us, and it's telling us where's our input, and the input is the raw data that we have here, and where are we expected to save our output, which is here. So we don't have to hard code anything. Plumber knows that if we save upstream equals this list with get, it's going to give us this information, and then it's also going to add this information from the pipeline YAML file. So we can just continue coding interactively, right? I'm going to copy the snippet here. What I'm doing here is I'm loading the raw data, so the output from the previous task. I'm just generating a new column, simple multiplication here, and then saving the output. I actually have to execute this before. Okay. What happened here? Oh yeah, we are missing the output folder. That's fine. I'm gonna run this from the command line, so we don't really have to run it for now. Let me open the other one. Great, okay. So same story here. We are just generating some features. So what I'm going to do is exactly the same thing. I can reload to show that this thing is working. And let me add the code. So we essentially doing the same thing. We are just taking a different column, generating a new column from the raw data, and then saving the file. So really simple thing. Now, this is where things get more interesting, because now, well, this is actually going to be simple. This is the task that joins the previous three files. So same idea, we are going to use get, feature, sepal, oops, feature, petal. These are our inputs. Let me reload this to show you that this thing is working. Okay. Now we just need a couple lines of code because we are going to be joining our data, and that's it. So now let me execute this from the command line, so we are sure that we have everything to code the feed.py file. So let me execute this Plumber build partially because we only want to run until the join task. We don't have the feed.py code, so that's going to break. So that's why we tell Plumber to only execute the first 4 tasks. So you can see that it's running get, and then it should execute. It's taking a little while. Let's check what's going on here. Okay, it finished. Yeah. So feature sepal, feature petal, then joining. Okay, great. So we have the first 4 tasks, and now let me open feed.py, which is the last one. Okay. So let me move this. Yeah. No, I want this here and this here. All right. So now feed requires join, right? We need all the data. And so here we have the inputs and outputs, and now we have to code we have to train the model. So since I'm using Jupyter notebooks, I can do things interactively. And this is really helpful from the data scientist perspective because they can just try a bunch of different things. Sorry, I just ran this thing. No, I wanted to first import things so you can see how interactively I can do things slowly. So for example, if I didn't know exactly where to start, I would say, let's load the data first, let's take a look at it. Then I had this snippet already, so just trying to show how the experience could be for a data scientist. And then we would say, okay, let's split the data, the features and the variable that we want to predict. Then we split the data, we train the model, we generate some predictions, and then we want to evaluate our model. So we can print this classification report, and then maybe we can generate some evaluation chart here, and then maybe we can save the model, right? So we are doing these things interactively, but at some point we want to use the command line to make sure that we don't have any issues here, and if we execute this file from top to bottom, it's gonna execute correctly. So I just did things interactively, but then I come back to my command line interface and call Plumber build. Note what's gonna happen now. I already have until the task join. So I only need to run the feed.py script. You see Plumber skipped the first 4 tasks because they haven't changed. They are going to generate the same output. And this is really important for quick iterations. So let's see that in action again. I have to be fast because we have limited time. So I'm just going to make a small change here. I'm going to change one of the parameters of the model to say use entropy. Okay. Now let me go back to the terminal and execute Plumber build. And since I only changed one of the tasks, this is only going to run feed. You can see that now. Okay, great. Now, well, we have our training pipeline working from start to finish. Let's work on the serving pipeline because we want to generate predictions, and that's the whole point of deploying this thing. Okay. So let me close this, and now we have to create a new file. Right? And let me just go back a second to the training pipeline, because we are getting some historical data, and that's what happens when you're doing a real project, not this simple example. You get some historical data, you generate some features, so we get historical data, we generate some features, and we train a model. Now, when we want to use that model to generate predictions, we get some new observations, maybe the observations that generated in the last month or last week. Then we have to generate the same features, and this is really important. We have to do the same processing at training and serving time. And finally, we load the model and generate predictions. So you can see that this part is common. This part is common to both pipelines, the training and the serving pipeline. So what I'm going to do is I'm going to create a new file. So new file, and call it features.yaml. I'm going to remove this, okay? And I'm going to paste it here because I'm basically extracting what's common to both, so we can reuse that. And then I'm going to do import tasks from and features.yaml. Oops, okay, nice. So if I run this thing again, shouldn't be any change. We only reorganized stuff. Okay, great. So now it's time to work on the serving pipeline. Pipeline.serve.yaml. All right. So what do we have to do for this thing to work? Let me copy my snippet, and then I'll explain what's going on here. So this is our serving pipeline. What's going on here? Since we are going to be running this in AWS, each task is going to execute on a different container, so we have to communicate one task to the next one. That's why we have to configure the S3 client, and this is an addition. We didn't have this for the training pipeline. Then the same thing that I did for the training pipeline, we have to import the tasks from this file. And then we have these two new things, because when we are serving predictions, we have to get new data, we need to get new data, and we have to make predictions. And one of the parameters for the prediction task is the path to the pickle file. And that's it. Now let's actually move the model that we just trained. Let me put it here because we need it here. Okay. Now we have to create the code to configure the client. So let me create another file, clients.py. This is going to configure our S3 client. So really simple thing. We just have a function. We are using Plumber clients, and then we return an S3 client. We're going to be using this bucket and this folder, and we're going to store our credentials in this file. Okay, what are we missing? We have to copy our credentials. Okay, yeah, we need that file. What else? Let's create the files that we are missing, because we have to add two new things here. So Ploomber scaffold, but this time use pipeline serve YAML. Okay, great. Now we have two more files here, and let me open this. So this is the code that gets new predictions. I'm gonna reload the same data. This is just an example. We don't have more data, so I'll just reuse the same one that we had before. But bear in mind that in a real world project, we would get new observations. Okay, so that's it for new.py. And for generating predictions, so same thing, really simple snippet. And we actually have to change this because we need join as an upstream dependency, and then we just have a couple lines of code that read the data and then generate predictions. Okay, so I think I have everything I need, but let's make sure. Let's do Plumber build. Let's see if everything's working fine with our serving pipeline. And if it doesn't, then we can just fix the errors. That's why. Okay, we had some issue. Oh, okay. I see what's going on here. It's the predict file. Let's see what's going on there. Okay, so we have Oh, I think we are not passing this parameter. Okay, yeah, we are calling it path to model, and here we are using a different name. Yes, that's the reason. Okay, let me just change this real quick. Okay, let's see if this thing works now. If it works, then it means that we can generate predictions. So we train a model, then okay, yes, finally. I think I just have to modify this because I have to declare all the parameters that I pass in the pipeline YAML file. I have to declare them here, so it validates the parameters in the Python file. So it should be fine. Now let's see what happens. And if this runs, then we are ready. Okay, yeah, things are working. We are getting some new observations. Now we are generating the features, another feature, and then joining the data, and now generating the prediction. So we are using the model that we trained to generate predictions. Awesome, we got this working locally. Now we want to run this in production, so we are gonna run this in AWS. All right, so what do we have to do now? We have to use another package that we are working on. We are developing called supervisor, and then we have this serve configuration. The backend is going to be AWS Batch, but this also works with Airflow and Kubernetes using Argo workflow. So it's the same thing, just small changes in the configuration, but it's the same for the most part. Okay, so it's adding some configuration for us. It's adding a few files, so let's give it a few seconds. All right, so now we have this new configuration file. This is where we need to configure AWS Batch. So let me just paste my configuration, and a bunch of things are happening here. We are configuring the containers and some settings for AWS, and then we don't want to include the environment files and the outputs, the local outputs. So I think we're ready. We just have to configure a few things here, and let's make sure that everything's working. So let's execute Plumber status to see if everything's working correctly. But yeah, it sounds like we are almost ready. Okay. So now let's configure my terminal for AWS, and now let's execute this thing. Supervisor export train. All right. So I think we are gonna finish early. That's great. Oh, it's not train. My bad. It's serve, because we want to deploy the serving pipeline. So it has to be serve. That's the name that we put here. Okay. So what's going on right now? Our command, the supervisor package, takes all our code, makes a few checks, ensures that everything's working correctly, and then it's gonna generate a Docker image, and then push it, and then orchestrate with AWS Batch. Well, I think something. Let me see here. Low increment. Okay, yeah. I have to make a change here. Mode force. Yeah, that's because I executed this before, so that's why it's saying, well, I don't have anything to execute. But now I'm gonna tell AWS to execute regardless of anything that I executed before. Okay, so now it's loading my pipeline. It's gonna ensuring that everything's working correctly. So it's gonna create the Docker image. It's gonna push the Docker image, and then it's gonna execute my pipeline. So you can see right now that it's copying the files. Now it's building the Docker image. So this is going to take probably about 2-3 minutes, I think, because it has to install all the dependencies inside the Docker image. So we are going to use the magic of pre-recording, and we are going to skip until this docker build command is done. Okay. Okay, so we finished creating the Docker image. Now we are pushing the image, and it's taking, it's going to take maybe 2 or 3 minutes to finish uploading. So we are going to skip until we finish pushing the image. Awesome, so it finished pushing the image. Now we can see that it submitted the tasks to AWS batch. Submitted, and let's go to the AWS batch console. You can see that it has these new pending tasks. Takes a few seconds, or maybe it's going to take a minute because it has to create the instances. So I'm just going to skip about a minute. So we see when this is finished, when it finished executing our serving pipeline in the cloud. Okay, awesome. This is the AWS batch console, and we can see that all our tasks executed successfully. And let's go to the S3 bucket. We have this folder, and we can see everything here. We have our predictions here. We executed things in the cloud, so everything's working in the cloud. Everything's working. Great. We finished early. So just some final words in terms of what we did is we develop a machine learning pipeline entirely using Jupyter. And when I was working on the code, you could see that having Jupyter was really helpful for me because I could execute like 1 or 2 lines, get some results, and execute the following line, modify a few things, and I had to do things really fast. But it's really important to stress that importance that when you are working, that's why data scientists like Jupyter Notebook so much, because it allows you to try new different things, and you can get the results, get tables, get charts, see the data, compute some numbers, and that's incredibly helpful. So the idea of Plumber is to bring all those software engineering best practices like maintainability, modularization, to help data scientists use the tool that they like, that they are the most productive with, but at the same time helping them build pipelines that you can deploy to production without having to take a notebook, refactor it, and then deploy. Because as I explained at the beginning of the presentation, that's a risky strategy and it doesn't work. It slows down progress. So that's why we want to use, that's why we developed Plumber in the first place, because we want to streamline this process and want to take things from Jupyter to production without anything in the middle. So let's keep in touch. You can check out the GitHub, the source code. You are going to find, you'll find the links to the documentation and to many of the examples that we have. Please show your support with a star on the repo. If you are interested in joining our community, please click on the GitHub's README, and you can follow us on Twitter to get news. What are we doing? What new features we are adding? And you can also reach out to us if you have any questions. So I think we still have time for questions. Thank you so much for joining today, and I hope you enjoy this presentation.